Hi and welcome to another video from the Intelligent Auto channel. Today we have this 2008, it's a Renault Keleos, it's a 2-litre diesel DCI, it's the M9R engine. Customer complaint is the car won't start. Crank it, tries to start, but fails to start. So first of all, let's get the diagnostic tool on it and see if there's any fault stored. So here we are, we're in the vehicle. Read the DTCs, as you can see, no fault stored. So I'm just going to prove this fault to you. As you can see, no warning lights come on the dashboard. Apparently the car just cut out on the road. So after that, still no fault stored. So next thing, I think, is to look at some data streams for this car. What I like to do with any non-start vehicle is pick some significant data streams. Now, this is a diesel engine. Got to think about what does it need to run. It needs fuel, it needs air, it needs engine speed for the injectors to trigger. It needs synchronization. The injectors clearly are triggering because it's trying to start. So let's pick up some data. So we'll look at the boost pressure, which is actually the manifold pressure on this car. Look at the engine airflow, engine speed, the rail pressure. I'm sure there's a one for synchronization as well. Synchronization. So we'll select them. I have to put it that way to get all the data PIDs in. I'll put it up on the dashboard. So there we go. So we've got manifold pressure looks plausible at 997 millibar. Engine's not running, so it's basically reading atmospheric pressure. Engine airflow is 0, which it should be. The engine's not running. Speed is 0. Rail pressure 6 to 8 bar, which will just be a residual pressure in the rail. There's no synchronization yet because we haven't tried to start the car, so let's go for another start up. So rail pressure's reaching an adequate level. We've got engine speed. Let's try to start there. We've got synchronization. The boost pressure's not really deviating far away from where it was, and we've got a measurement of airflow. First thing that strikes me is the engine airflow. I've purposely chose the data PID milligrams per stroke. This is a 2-litre engine, so even it doesn't matter at what engine speed. If there was no turbo boost, so if the manifold's at atmospheric pressure, I would expect to see an engine airflow reading of around about 500 milligrams per stroke. So this could suggest that there's a blockage somewhere, there's a restriction in air. Could this be a blocked exhaust? Could it be a blocked air intake? It's all possible. Could it be a blocked air filter? It's possible. Now, using the boost pressure alongside the airflow, if I had a blockage in the air intake, I would expect the boost pressure to drop because there'd be a vacuum starting to build in the manifold. Also as well, if there was a blockage in the exhaust as well, I would expect the boost pressure to drop because of the restriction in the exhaust will manifest itself as a restriction in the intake as well, because the turbo will stall and the flow of air into the inlet manifold would be restricted. So again, it's like, might as well stick a rag down the air intake. It would have a negative effect on boost pressure. So let's watch that boost pressure again. As you can see, it doesn't really drop. See, the standout data PID for me is engine airflow. And the reason I've done this video is I've already diagnosed this car. Is with most modern ECUs, you have what's called substitute values. So basically, if you unplug a component, a measuring type component, such as a boost pressure sensor or an airflow meter, the engine ECU will substitute the lack of feedback with a known good feedback. So next thing I'm going to do is I'm going to unplug this airflow meter. That's it unplugged there. Our airflow is still sitting at 0. But when I start it up, it'll start. It's a Renault, you've got to jump through hoops with these things to get them to start. There we go. The engine runs. Now look at the airflow. Substitute value 550 milligrams per stroke. So even though the airflow meter is disconnected, the engine ECU has substituted the value of the known good value, and it's allowing the engine to run. So just to prove that the airflow meter is the issue, as soon as I plug it back in, engine stalls. Now, some of you will be saying it's got a blocked air filter. Somebody's already been here before me and they've replaced the air filter. So it's not a blocked air filter. So let's have a look. Airflow meter is still disconnected. We'll start it back up. Let's look at the rest of the data PIDs. Rail pressure is good, 350 bar at idle, which is about where I expect to see on this vehicle. Boost pressure is good, give it a rev. Boost pressure rises as it should, so indicative that there's no blockage in the intake system and there's also no blockage in the exhaust. Also rail pressure rises exactly as I would expect it to. So again, indicative that there's no issue with the high pressure fuel system. So basically, the low airflow reading before we were getting, I think it was something like 40 or 50 milligrams a stroke when cranking. What that's doing is, as you saw, the rail pressure rises where it fails to start. What it's doing is the engine ECU is backing off the amount of fuel injected, because the amount of fuel injected is relative to the amount of air coming into the engine, so it can maintain a good air fuel ratio. So bad airflow meter, non-start, no fault stored. What I've done is I've removed the airflow meter from the car. As you can see, it's pretty badly contaminated with oil. So I'm going to give it a clean up, put it back in and see if it comes back to life. Oh, shoes. Bit of brake cleaner. It's a bit cleaner in there now. back in and try it, eh? Slot that back in. There, no need to put any screws on. Plug it back in. Let's see what we've got. There we have the engine airflow again. It's there. Bingo. So, oil contamination on an airflow meter. What could have caused that? There was a brand new air filter fitted to this vehicle. So my suspicion's been that there's been an airflow fault previously with this vehicle and somebody's replaced the air filter. If the air filter that came out was heavily contaminated, what that could cause is it could cause oil to end up getting pulled back towards the air filter from the breather system. So this could have contaminated that airflow meter. So let's have a look at some evidence. You see, we've already seen it's got a brand new air filter fitted, but if we look at the fuel filter, it looks older than me, and I'm 52. So it would indicate that the car has not been serviced recently. As I say, the fact that that has never been changed would indicate that probably that's been overlooked as well. So what's been the cause of the breakdown of this car? Probably bad servicing from the start. So I'm going to call that a fix. Thanks for watching. Hope you took something from this video. They say the substitute values certainly is a good test for most feedback sensors. If you unplug them, most ECUs will actually replace the value with a substitute value, which is a known good substitute value. There will be exceptions to that, rail pressure sensors and stuff like that. Reason being is for safety. If it doesn't know what the rail pressure is, then it could become dangerous and damage the engine. But airflow meters, map sensors, temp sensors to a degree, unplug them, see if you get a substitute value. If you get a substitute value, use it as part of your diagnosis. Thanks for watching.